You're holding a small fossil fragment, cold, heavy, and chipped along the edge like a blade that once struck stone and bounced back. It doesn't look like a tooth, doesn't look like a claw, but it has a very particular vibe. This used to be a weapon. Fossils usually sit politely in glass cases, scrubbed clean, looking harmless and well-behaved. Truth is, a lot of them are closer to evidence. Wipe off one thin layer of dust, and suddenly a hunt from hundreds of millions of years ago feels uncomfortably present. And this is where it gets nasty sometimes. One sliver of bone is enough to make your brain hear a jaw snapping shut. Put it this way, some predators didn't need shiny rows of teeth to make the ocean nervous. They had mechanics. Take Dunlopius terrelli. It's the sort of creature that makes armored feel like an understatement. Its head was wrapped in bony plating, thick and brutal like a medieval helmet designed by someone with anger issues. But the real headline isn't just the armor, it's the mouth. Because Dunlopius didn't rely on a classic shark tooth setup. Instead, the front of its jaws carried heavy bony plates that functioned like self-sharpening blades. When it closed its mouth, those plates slid past each other and honed themselves, basically a set of industrial shears that never needed a whetstone. Funny image, sure. The outcome, not funny at all. Estimates vary, but the popular ballpark puts a big Dunlopius at around 6 meters long and roughly a ton in mass. Biomechanical models suggest bite forces around 4,400 newtons at certain positions and potentially stronger, deeper in the bite, depending on where the force is applied. Numbers can sound dry until you translate them into what actually happens. This wasn't a predator that simply held on. It cut, one decisive clamp, and the prey wasn't arguing its case anymore. Here's an extra detail that's oddly frustrating. Armored fish fossils often preserve the armor beautifully, but soft tissues like cartilage almost never fossilize well. So we get a very clear look at the plating and the cutting edges, and a stubborn blind spot for what the full machine looked like inside. That gap is where the mind starts filling in the blanks, and it never fills them in with anything cheerful. You see the slash marks, but you don't fully see the hand that swung the blade. Now, if bone blades feel like the peak of prehistoric weirdness, hold that thought. Because ancient seas didn't stop at knife, they went straight to power tool. Enter Helicoprion, a creature that basically arrived with its own built-in argument for why evolution doesn't care if a design looks sensible as long as it works. The fossil clue is famous, a spiral tooth whorl, a coil of serrated teeth that looks like a circular saw had a baby with a spring. For decades, more than a century, scientists debated where on Earth, or in this case, where in the fish that spiral belonged. Nose fin, somewhere awkward that made old reconstructions look like an illustrator's nightmare. Then modern imaging flipped the lights on. CT scans and 3D reconstructions show that the tooth whorl sat in the lower jaw, curled inward and functioned like a cutting and feeding mechanism, slicing prey and drawing it deeper into the mouth as the jaw closed. Classic specimens have spirals around 23 centimeters in diameter with up to 117 teeth. New teeth kept growing and pushing older ones along the conveyor belt like a production line that never clocked out. And here's the unsettling bit. Once prey entered the pull zone, backing away wasn't really on the menu. It wasn't just bitten, it was processed. Evolution at times behaves like a cold engineer. Forget aesthetics. Does it run reliably? But that thought triggers another one. Even worse. Alright, there's a saw in the mouth. So who catches you before the saw even needs to spin up? The water is murky. Light filters down in smeared greenish ribbons. The seabed is a long corridor of shadow and silt. Something lies low and still, so still it could be driftwood. Sure, underwater everything can be driftwood, until the driftwood has claws. Megalodon, Renanii, the giant sea scorpion, often described as the largest known arthropod. A lot of what we have are fragments, parts of claws or limbs, but scale comparisons and proportional reconstructions suggest it may have reached about 2.5 meters in length. Say it like this: if a sea scorpion is longer than a full-grown adult, suddenly the beach becomes less romantic getaway and more legal disclaimer. Megalodon didn't need a shark's bite. Its weapon was the clamp, grabbing, pinning, crushing. In cloudy water, the most dangerous predator isn't always the one that's fastest, it's the one you don't register until the distance has already collapsed. The scariest thing about ambush is the lack of warning. You don't get a dramatic build-up. You get a moment of realization, and then consequences. The twist here is how we know it. Piecing a predator together from scattered fragments means science has to rebuild the animal with logic and proportion, like assembling a jigsaw puzzle where every missing piece might have been capable of biting back. But once the picture comes into focus, the message is clear. Ancient seas weren't only home to big, they were home to quiet. And quiet predators don't announce themselves with noise. They announce themselves with sudden absence of options. From the seabed, the story naturally drifts shoreward like a tide dragging silt and leaf litter into a swamp. On land, or at least in the steamy edges of ancient tropical forests, there was a fear that turned walking past the waterline into a genuinely questionable decision. Titanoboa cerrejonensis is known from enormous vertebrae found at the Cerrejón coal mine in Colombia, the remains of a prehistoric tropical rainforest. For snakes, vertebrae are practically signatures. Shape and size can tell you an awful lot about length and build. Estimates commonly place Titanoboa around 12 to 13 meters long, with a mass in the neighborhood of 1.1 tons. A snake that weighs about as much as a small car, except it doesn't need roads. It just needs you to be in the wrong place at the wrong moment. And here's the clever part. Titanoboa isn't just a monster. It's a thermometer. Snakes are ectotherms. Their physiology depends heavily on external temperature. The bigger the snake, the warmer the environment generally needs to be to keep it functioning efficiently, moving, hunting, digesting. That's why Titanoboa's sheer size suggests the tropics back then were hotter than today, with some models indicating average annual temperatures in the range of roughly 30 to 34 degrees Celsius to support an animal of that. Put bluntly, one vertebra can read like an ancient weather report. Only this weather report can crush you into punctuation. Once the mind accepts that a swamp can produce something that heavy, it naturally slides back to the ocean, because sometimes the only evidence you need is a single tooth, and the room goes quiet. Otodus Megalodon. Its teeth are thick, triangular, weighty, and finely serrated like a butcher's blade designed to stay sharp through unpleasant work. The strange irony is that we have loads of teeth but relatively little of the body preserved. It's like a case where the weapon is everywhere, but the suspect's face is missing from the file. Still, teeth plus bite marks on prey bones plus the rare vertebral remains let scientists build a chilling profile, a giant predator of warm seas, taking on whales and other large marine animals. Some estimates put its bite force as high as about 41,000 pounds, roughly 182,000 newtons when converted. But the true shiver isn't the number, it's how the number was used. A wide, gaping jaw, multiple rows of serrated teeth built to grip and slice, turning a single bite into a cutting event. And this is where it gets nasty. Megalodon's teeth aren't just big, they're right. Optimized for sawing through flesh and holding on to struggling prey with ruthless efficiency. You don't need to debate how intelligent it was. One look at the hardware tells you the job description. The mini twist that keeps the mystery alive is simple. Lots of teeth doesn't mean we know everything. Teeth fossilize easily, soft tissues and full body outlines do not. So, the exact proportions, how deep-bodied it was, how thick the muscles were, the finer details of the silhouette still carry uncertainty. That uncertainty is a magnet for exaggeration, sure, but it's also genuinely exciting because it means the scientific story isn't sealed. Every new find is another line in the report. The file is still open. Now the pace needs to change just briefly so there's room to breathe. Not to relax, though. More like taking a breath before the next strange turn. Because prehistory wasn't only bigger and stronger, it was also what on earth am I looking at, as if life tried every rough sketch before settling on the modern designs we recognize. Hallucigenia is a perfect example. A tiny Cambrian creature with a soft body, multiple spindly legs, and a row of spikes along its back. It looks like a fever dream rendered in biology, except it was real. A reminder that nature has never been shy about experimenting. Then there's Platybelodon, the so-called shovel-tusked proboscidean from the Miocene with a lower jaw and flattened tusks shaped like tools. It doesn't try to look impressive, it tries to work. Cutting, scraping, processing, vegetation, turning anatomy into hardware. That's the running theme, really. Evolution doesn't care if something looks elegant, it cares if it functions. If the answer is yes, it stays whether or not anyone finds it comforting. So here's the closer Earth didn't need dinosaurs to be packed with real living nightmares. Evolution isn't interested in what humans fear. It's interested in what survives and what succeeds, no matter how strange, no matter how brutal. And if it feels like titanoboa should be the upper limit for giant snakes, pause there for a second. In recent years, scientists have described another massive extinct snake from India, Vasuki indicus, dating to around 47 million years ago, with estimates suggesting it may have approached roughly 15 meters, meaning the ceiling might not be as fixed as we'd like to believe. Next time it gets properly forensic again. One bite mark on a bone, one groove, one tooth scar, and the goal is to reconstruct an entire hunt from the first approach to the final struggle, like replaying footage that's been buried inside stone for millions of years.